Mr. McDonald, just before the break, we were talking about pesticides and the ability for you to understand where pesticides were applied geographically in the province through the data that's currently available. And you indicated that there was no way right now to understand where the geographic location of pesticide application or the concentration or timing of pesticide application. Would that information be important to have to properly assess pesticide impacts in the province and on the Fraser watershed?
Yes.
Why?
Well, let me answer that with an example. Typically what has been done historically with pesticides is that legacy pesticides like the DDTs and the chlordanes and the endrins and the eldrins, those are the ones that are incorporated into monitoring programs, either of sediments or fish tissues. What's been missing has been information on in-use pesticides. And just to sort of illustrate the importance of in-use pesticides, I'm involved right now in a study with the USGS, the U.S. Geological Survey. And the study involves collecting sediments around, in small streams around major urban centers throughout the United States. So Dallas, Seattle, a variety of other places throughout the U.S. And the study was designed to look at a broad suite of contaminants, metals, PHs, PCBs, a variety of legacy pesticides, but it also included a number of in-use pesticides. Things like pyrethroid pesticides, which are things that are now broadly used but are not broadly measured. And what's interesting about this study is we looked at toxicity to a suite of sediment-dwelling organisms, midge, little non-biting flies, amphipods, which are little crustaceans, and freshwater mussels, which are bivalves. And when we look at the exposure information and the effects data together, the metric that provided the best basis for understanding toxicity was pyrethroid levels in the sediments, bifenthrin specifically. And so it's clear that across certain places that we're looking at right now, these in-use pesticides are important. And some of these ones that we've never paid attention to before are so important that they are actually driving toxicity to some of the organisms that are out there being exposed to it. So that's why it makes it so important to have this kind of information for the Fraser River Basin as well.
Another industry that you've mentioned in your report is pulp and paper. We've talked about that a bit already today. Do you have sufficient surface water and sediment chemistry data to assess contaminants associated with pulp and paper?
No.
And is the kind of data that you would require difficult to collect?
I would have liked to have had that information to support this assessment, yes.
All right. Is that kind of data being collected right now in the pulp and paper industry that you're aware of?
No. The suite of contaminants that are typically being measured, either in effluent or in the receiving water system, is a fairly narrow range of contaminants and doesn't really reflect all of the kinds of contaminants, or even a large subset of the kinds of contaminants that we identified as being associated with those types of effluents.
And is there any technical obstacles to the collection of the kinds of data on the contaminants you're talking about that aren't being collected now? No?
Not that I'm aware of.
Same question for wood preservation facilities. Is there sufficient surface water and sediment chemistry data to assess contaminants associated with wood preservation facilities?
I don't believe so. We were unable to locate it.
And again, is there any technical obstacle to the collection of data from those facilities?
No.
What data is available to understand concentrations of surfactants and fire retardants in the Fraser watershed?
As far as I know, there's very little data available right now. So surfactants, it's a general term for this group of contaminants that are like the alkyl phenols that are used as emulsifiers, or they're used to change the surface tension of liquids, essentially. So they allow you to mix things more efficiently, two types of liquids more efficiently, or they're used as dispersants if in certain types of spill situations. And then the fire retardants you're talking about are things like the PBDEs, the polybrominated biphenyl ethers, that have characteristics very much like PCBs, the legacy contaminants. And what we know about certain things like these classes of contaminants, that the concentrations have been increasing rapidly in receiving water systems around the world, but there is evidence also from BC that suggests that things like the PBDE concentrations have increased dramatically over the last 10 years. And the quick answer is there's very little information, though, with which to evaluate the concentrations or potential effects of those contaminants in the Fraser River Basin.
And is it possible to collect that data?
Yes.
And what data right now is available to understand concentrations of some of the hormone drugs that we've talked about already today, hormone levels of pharmaceuticals, personal care products, disinfectants and their byproducts, and nanoparticles? What do we know about that right now?
I was unable to locate data on any of those classes of contaminants for the Fraser River Basin. I know that there's a pilot study ongoing in Victoria by the CRD, but I was unable to locate that type of information for the Fraser River Basin.
And what are nanoparticles?
Nanoparticles are they're basically very small particles that have specific properties. And they're less than 100 nanometers in size, so that makes them very small. And they are used in a variety of applications, some of them in biotechnology, so they can be used to deliver, for example, antibiotics or chemotherapeutics to specific sites in a body, but they're also used in a number of industrial applications as well.
All right. And could that data be collected?
Oh, yes.
So we've reviewed now a lot of contaminants that you were not able to assess. How significant to Fraser River sockeye are those contaminants that you were not able to assess?
Well, because we were unable to assess them, it's hard to say how important they were. What I can tell you is that things like the volume of discharges from wastewater treatment plants have increased in the last 20 years. Human populations have increased throughout the Fraser River Basin. It's not surprising then that we've had increases in the volumes of those discharges. And many of the contaminants we've been talking about are associated with discharges from wastewater treatment plants or from other types of industrial activities. So I think it's important from the standpoint that we think the concentrations are increasing, yet we haven't had the data to evaluate them. So quick answer is, I don't know what the answer is, but I'm concerned enough that I think it should be on our list of things that we should be looking at very carefully.
You've referred to periodically in your report total suspended sediments or solids. Are those monitored right now by any branch of government?
Yes, it's total suspended solids, which is an indication of the level of suspended sediments in receiving water systems, are typically included in most of the major monitoring programs that are being conducted, either at the federal sites or the provincial sites around the province, and they're typically measured also in effluent. What's missing for me is measuring TSS concentrations, total suspended solids concentrations, in the vicinity of where the sockeye are actually spawning. So the concern is that you might have, for example, as a result of increased forest management activities associated with, for example, pine beetle, salvage logging, those kinds of things. You may have large areas of the landscape that are deforested. As we get precipitation in those areas, we have erosion. That erosion leads to the release of these fine sediments into the receiving water system, and they can either be carried along in the flow, in which case they get into the gills of fish and can cause toxicity, or they can be deposited in the stream substrate where the eggs are. And when that happens, it creates a layer on the bottom, and that can suffocate the eggs if they're not getting the flow and the oxygen to them. So even very conventional contaminants that are typically measured in these kinds of programs are very important, particularly if we measure them in the right places where the fish are likely to be exposed to them. And that's right where they're spawning and incubating.
And you might have already answered this question when we were talking about some of the earlier tables, but are contaminated sediments monitored right now in the province?
Yes, they are.
In what locations?
There are a number of monitoring locations throughout the province. In our report, we've identified a number of locations, in particular the Lower Fraser River area of interest, plus a few places in other locations. And they're being monitored, I believe, by various interests. And so we were able to access data that were readily available from the EMS system that we talked about earlier. I believe that the data on the concentrations of contaminants in sediments are also being included as part of the pulp mill monitoring programs, for example, the municipal wastewater monitoring programs. But the challenge that I see in having these this kind of data generated in multiple, somewhat disparate monitoring programs is that it's hard to bring it together and develop sort of a comprehensive picture of what sediment contamination looks like across the Fraser River Basin. Some of the data is readily available, like the EMS data. Much of the data is not readily available, and that represents a problem.
Was an issue for spawning sockeye. So I think I'll move on, but I'll ask you if contaminated sediment is an issue for sockeye rearing habitats.
Yeah. Most sockeye salmon are using nursery lakes, and so they're up in the water column and they're feeding on plankton, and so they're not getting very much exposure to those contaminated sediments, apart from what might be accumulating in the food web. That way. But certain stocks, like and Harrison is one of them, utilize habitats within the lower Fraser River and estuary during their brief, relatively brief compared to other sockeye stocks. They're rearing in these backwater areas in the lower Fraser. Those are the places where they're feeding on amphipods and other invertebrates that are associated with these finer sediments, the soft bottom sediments. And that's where they can potentially get exposure to the contaminants that are associated with those sediments.
And are there effluent discharges into any of the rearing lakes in the province?
As far as I know, there are that occurs in only a few situations. And by that we mean either major industrial or municipal discharges. Mm-hmm. And so there would be only a few examples of those in the province.
Do you know which ones they would be?
I believe that Endako Mines has a discharge into Fraser Lake. And there are some discharges upstream of Kamloops Lake as well, and to what extent the sockeye are using that water body, I'm not entirely sure, but if they are, there would be some interaction with those discharges as well, both pulp mill and municipal wastewater.
Did you look at the interactive effects of temperature, disease, and contaminants?
I did not.
And has any work been done by others in that area?
I'm not aware of a specific work that has looked at all three of those elements. There's been a variety of studies that have been done on the interactive effects of temperature and the pathogens in salmon. There's been studies that look at contaminants and pathogens in salmon as well. Some of the studies that have been done by the National Marine Fisheries Service of the National Oceanic and Atmospheric Administration. But if there's studies that have been done where we look at the interactive effects of contaminants, temperature, and pathogens, I'm not aware of those.
And is that, are those interactions significant in any way? Should there be work done on that area?
I believe so. I've looked at a series of studies that have been done by others around North America, and what it shows is that there are strong interactions between contaminant uptake in juvenile salmon, specifically Chinook salmon is what has been looked at in the past, and their ability to acclimate to salt water and their disease resistance. So when you look at those two factors together and you see that contaminant exposure impacts potentially immunocompetence, and you know that there is also an interactive effect between temperature and pathogens, as was indicated in some of Scott Hinch's work, which I believe we've already heard from, then it's logical to look at the three of those factors together and determine if the potential effects are even greater than what we might expect looking at either of those two individually.
When you completed your analysis of the contaminants of emerging concern and the endocrine disrupting chemicals, did you form an opinion on whether the presence of those contaminants was explanatory of the declines in Fraser River sockeye over the last 20 years? Or in 2009 in particular?
I did.
How did you describe the assessment that you did and how you arrived at your conclusion?
So what I did was I looked at sources and releases of these kinds of contaminants. I looked at potential effects of these contaminants on sockeye salmon, salmon in general, fish in general, integrated that information, and then integrated that information using something we call an eco-epidemiological approach. And I apologize for those who have to type that in the machine in advance. And what that approach does is it looks at 5 different characteristics of causality. You know, things that you would expect to see if there was a causative relationship between the concentrations of contaminants in the watershed and the declines of sockeye salmon that we've seen either over the last 20 years or more specifically in 2009, where we had the very low returns relative to expectations.
Okay, and what was your conclusion?
My conclusion was that it's unlikely that contaminants was the primary factor causing either the decline in sockeye salmon in 2009 or the declines that we've seen over the last 20 years. But I also concluded that there was a strong possibility that contaminant exposures was a contributing factor in those declines over the last 20 years.
When looking at the impacts of pollution on Fraser River sockeye in relation to the 2009 decline in particular, would it be appropriate to restrict your analysis to whether there had been a Fraser Basin-wide environmental incident that could have impacted the fish in that year?
In my opinion, that would not have been the way to do it.
Why not?
It is premised on the assumption that there would need to be a very large, for example, spill or some other effect that would be very obvious to and well recorded in the literature for there to have been an effect of contaminants on sockeye. Well, that assumption, I believe, is true. I think we have all the necessary and sufficient conditions to have contaminants represent a significant contributor to adverse effects without this sort of large, almost apocalyptic effect that you just described.
40 and 141, you set out a number of recommendations. They break down generally into some recommendations on monitoring, recommendations about coordination of information gathering, and some recommendations on research. So if I can just, the monitoring recommendations are very clearly set out, and I don't want to go through them one by one with you, but if there's, I'd just ask you if there's anything you'd like to highlight today in the monitoring recommendations.
Yes, there is. If that's okay. So the monitoring recommendations really get at, we identified what data were available, and most of these monitoring recommendations lay out what we would need to do to provide or to generate the kind of information that was missing to support this type of evaluation. So it lays out the where and the when and the what's to look at, I think, reasonably clearly. What might be easy to skip over in these recommendations is something that is embedded in one of them that calls for the design of a cumulative effects monitoring program. And that's, you know, we sometimes when we look at these kinds of problems that emerge in the environment, we're looking for that one thing that explains all the effects that occur. Where in fact it's more the concept of the 1,000 cuts that is creating the problem. And so the design of a cumulative effects monitoring program allows us to, one, look at all of the activities that are ongoing within the Fraser River Basin, identify the types of changes in the characteristics of the ecosystem that are associated with each of those types of activities, and collectively with those activities to develop some predictions about what the cumulative effects of all of these activities might be, and then allows one to then do some very structured or focused monitoring that allows us to, one, determine what the characteristics are, the physical and chemical characteristics of the receiving water system, so that we can evaluate exposure and effects, but also importantly, it allows us to evaluate the responses of the organisms that we're most concerned about, in this case, sockeye salmon. So we want to be able to make some hypotheses about what cumulative effects might be, and then be able to design a sampling and monitoring program that actually is targeted on what those effects might be, so that we're measuring the right things in the right places to be able to draw conclusions about what are the things that are actually affecting the declines of sockeye salmon that we've seen over the last 20 years, and be able to hopefully better understand what are creating these fairly atypical returns like we had in 2009 that are difficult to explain right now with the data that we have available to us.
And you also suggest that your table 8.1, which is the table we went to this morning, setting out all the different classes of contaminants and then the individual contaminants within each class, is something that could be used. Can you explain how that would be used?
Yeah, what we've tried to do in our evaluation is to look at land uses in such a way that it enables us to, on an area of interest by area of interest basis, identify the classes of contaminants that are most likely to be released into receiving water bodies within that area of interest. And so by looking, for example, at the Pitt River system and going down this list, it would help us, using this table 8.1 as a guide, it would allow us to focus monitoring activities on those things that really are being released into the Pitt River, so that we're not spending a lot of resources collecting information that is unlikely to be useful as we're trying to explain interactions between the characteristics of the environment and the responses of the sockeye that are utilizing those habitats.
On page 141, the top recommendation that you make is top in the sense of being the first bullet on the page, is coordination amongst government agencies and regulated interests should be improved to ensure the requisite data are being collected and are compiled into a single database or multiple databases that are compatible. Can you explain where the concerns, where that concern came from that prompted this recommendation, and just explain a bit more about what you're thinking of?
Yeah, so as we've been trying to collect and collate this information to support this analysis, what has become apparent, certainly was apparent in the past, but it's certainly no different now, is that there are a number of organizations throughout the province collecting different types of data for different types of purposes, and that data is frequently held in various locations that are not all readily available. And it would be very helpful to be able to coordinate, and it would be cost effective as well, to coordinate the collection and collation of that type of information into a single database, or at least databases that are readily available and that can talk to one another very easily. So it doesn't require a lot of data translation steps. having this kind of coordination would allow everybody to have better access to data that can be used in a variety of different ways. For this type of evaluation like we're doing here, but also for the other types of evaluations that we know monitoring data is required for. If it's in one place or it's readily available, it can be used for multiple purposes.
And this would be agencies that would include the federal government and the province,
And First Nations.
First Nations and municipalities, and
Absolutely.
any other agencies that you can think of?
Yeah, it's basically all the regulated interests as well. Who's ever out there collecting data, that's required to collect data as part of their permitting process, all of this should come to one central repository that is compiled.
Today you've talked about the EMS database. Is that not sufficient?
There's nothing. We love the EMS database. We think it's a great tool. And what would make it a better tool is if we were able to compile data from other sources in there. And if it became a comprehensive repository for this kind of information, then its value would be even greater than what it is today.
And then my last questions relate to research. What, in your view, are the key data gaps which need to be addressed?
So there's a number of things that are sort of high on my list. One is the evaluating the toxicity of these endocrine disruptors and these contaminants of emerging concern to salmon. We've got some data for other ecosystem receptors, but very little data on salmon per se for a lot of the chemicals that are on that list. We talked moments ago about interactive effects of contaminants and disease agents and water temperatures. For me, this seems to me to be a very, very important area of investigation, because this effect of contaminants and water temperature and disease agent is potentially very important for the fish as they're out migrating out of the Fraser River and transitioning to their life in the saltwater system, but it's also potentially very important as they're returning adults, particularly in light of some of the changes that we're seeing in water temperatures in August and early September in the Fraser. So that's critically important. I talked a little bit about the cumulative effects monitoring program that I think is very important to move forward with in the near future. And then one of the last recommendations I had was to do a survey of disease agents upstream and downstream of fish processing facilities in the Fraser to see if there's any potential for that being a contributing factor to this sort of interaction between the water temperatures and the disease incidents that Scott Hinch has described in his work.
Thank you, Mr. Commissioner. Those are my questions. Sorry, the next question will be Canada. Mr. East.
Big event that happened in 2009 that you see perhaps more recently in the press about Gold Stream River, for example, with chum salmon, or the notorious incident with respect to Chiacamas River a couple of years ago. You didn't find any evidence of that kind of catastrophic event that would have demonstrated a high and obvious fish kill in 2009.
I was not aware of any event like that occurred. That's correct.
Okay. And so when we're looking at the issue of contaminants, I think gleaning from your report, I would suggest there's perhaps three themes, and I'll put these to you as questions. And I think they've all been covered to some extent already. First of all, to comprehensively answer the questions relating to the role that contaminants have played in the decline of Fraser River sockeye salmon, more data is required, more specific tools are required in the form of standards and guidelines, and more research and analysis needs to be done on the issues of contaminants affecting Fraser River sockeye salmon. Would you agree that that's a major theme of your report?
Yes, I would.
And this is particularly the case, as you've dedicated an entire chapter to it, chapter 6. This is particularly the case for the class of endocrine disrupting chemicals, and also and overlapping with these contaminants of emerging concern. That's a major theme, the need to do more work in these areas. That'd be a second theme of your report.
That's correct.
And finally, and I think this is something I want to explore a bit more with you, and you've just discussed this now, so I won't, maybe I'll just provide some examples to you in the time that I have. And sorry, Mr. Commissioner, I think that I will certainly be done prior to 4 o'clock today. When considering the role that contaminants may have played in the decline of sockeye salmon, it's important to look beyond the effects of the toxicity of contaminants that lead to issues of lethality, fish kills, for example, reproduction and growth. But look at the factors that may tend to weaken the salmon. That make them more vulnerable to other environmental or human-caused factors in the environment. Would you agree with that?
Not exactly in the way that you characterized it, but I would agree, so I'll characterize it in my own way. So I wouldn't look at sublethal effects in exclusion of the potential for lethal effects. And I'm thinking about things like suspended solids and deposited sediment in spawning beds. Those are factors that can cause very clear toxicity to salmon, and they're very important in determining their egg-to-fry survival rates and things like that. But in addition, now here's where I will agree, is that looking at the sublethal effects of these contaminants on salmon, I think, is critically important. It's clear that there are whole classes of contaminants that we've never looked at sufficiently in the past, and many of these act through mechanisms like changes in reproduction, changes in immunocompetence, that you cannot evaluate using sort of the classical toxicity test mechanisms that we've used throughout the 60s, 70s, and 80s and 90s to look at the effects of these contaminants. So that's a long-winded way of saying, yes, I agree.
No, and that's a crucial point, and I'm probably going to jump around to return to these 3 themes, and maybe what I'll do now is jump ahead in my own notes to maybe present a paper that I think you're familiar with, because you referred to it in your report, and that's by Johannesson and Ross, and that's tab 4 of Canada's list of documents. I think maybe this is a good example of perhaps what we're just talking about here. Now, this paper, and you've referred to it a number of times, so you're familiar with it?
Yes, indeed.
And just for the record, it's a 2002 report by Drs. Johannesson and Ross. It's called Late Run Sockeye at Risk: An Overview of Environmental Contaminants in Fraser River Salmon Habitat. And perhaps for the record, I'll just maybe go to the abstract, which is page Roman numeral 8. And the purpose I want to bring this to your attention again, Mr. McDonald, is just to use this as an example to demonstrate the importance of examining, or potential importance of examining sublethal effects of these contaminants. First of all, in the abstract, I just want to put this into context, and this is what the paper was looking at. If you look at the starting on the top line, Fraser River sockeye salmon utilize some of the most populated and industrialized regions of British Columbia during sensitive life stages. And this is another theme that I might want to come back to. Example, spawning, egg hatching, larval development, and migrations between fresh and salt water. Now, just stopping there, sockeye salmon, and salmonids in particular, would you agree that they are particularly sensitive species because of the nature of their life cycle?
Well,
in comparison to perhaps other aquatic species, for example, resident species.
Yeah, I'll answer this question by saying when we develop environmental quality guidelines for individual contaminants, what we find is that salmonids are generally the most sensitive species to the contaminants that we're looking at. You added something about by virtue of their life cycle, but they are inherently more sensitive to most contaminants than are other aquatic organisms, and that's important to keep in mind as well. But then also you added by virtue of their life history, and that's also true because they utilize so many different habitats throughout their life history, and each one of those habitats has the potential to be adversely affected by discharges of contaminants or other anthropogenic factors that influence their survival during those critical time periods. So, yes.
So one such example would be for anadromous fish, that critical and very vulnerable period in their lives when they convert from fresh to salt water or back from salt to fresh water. That would be an example of one of those kind of very vulnerable life stages.
Yes.
And another, I mean, and this is perhaps more general than just sockeye salmon, but I think it's a truism for many species that their early developmental stages in the life cycle of any species, but particularly for salmon, are times where particular care and attention needs to be paid to sensitivities during those very early developmental stages.
Yes, that's correct.
Okay. Continuing on with the abstract. So during the period from 1994 to 2001, pre-spawning mortality of adults associated with a change in migration timing increased from 10% to over 90% among late-run stocks of the Fraser River sockeye. And I think this is something that we've certainly been discussing in the context of this inquiry. I'll skip over the next line. It talks about the value of this lost harvest. Go to the next line. A contaminated associated impact represents one of several possible contributing factors touted in the sudden appearance of this mysterious phenomenon. So the purpose of this article, as I understand it, is to examine that perhaps contaminants in the ecosystem were one of the reasons why these late-run stocks were experiencing such high pre-spawn mortality. Is that your understanding?
Yes.
And perhaps I can just go to the page 1 introduction. This is page 13 on ringtail.
Thank you.
And here again it talks about, and this is called the problem. And this is the phenomenon where sockeye and certain late-run stocks traditionally would mill about back and forth in this Georgia Strait and the Fraser River estuary for 6 weeks before moving up into the Fraser River. And then the next line, this milling period began to decrease significantly in 1995, and concurrent with the early entry, the sockeye exhibited unusually high pre-spawning mortality. And it talks about in the next line, the trend increased to the point where the milling period in 2000-2001 had decreased to a few days, and the pre-spawning mortality had increased to more than 90%. Do you understand that this is still a concern with respect to certain late-run sockeye stocks?
That's my understanding.
Yeah. And then the next paragraph, there's evidence that the actual mortality is caused by an infection of, and I'm going to have trouble here, Mysosporidium parasite in kidneys of affected sockeye individuals. However, it is believed that the infection would not progress to a lethal level prior to spawning if the sockeye were not heading upstream earlier in the season. So in other words, this is a naturally causing parasite that normally would not have had this impact on the salmon if they had not entered this stream so early on. Am I understanding that correctly?
I believe that's what the words say here, yes.
So this is an example, maybe going to the next page, where it talks about the focus of the report. The authors hypothesize, it's the top line, that if a contaminant is to have caused this change in behavior, it must have increased in use sometime in the last 10 years. And this is the temporal correlation. And that's kind of a similar approach that you've taken in your report to try to correlate time periods of water quality plus with evidence of decline. And here, and I think this is crucial, this is what I really wanted to focus on, under known contaminant effects of fish, the object of this study is not to identify contaminants that might be killing sockeye salmon. We're not looking at evidence of direct lethality to the salmon. The goal is to identify contaminants that could alter the normal return migration timing pattern through sublethal effects. And the following are recognized sublethal effects of some contaminants which could result in the observed behavior change. So here's an example, and I'll get into it in a second, where the report is not looking at what actually necessarily killed the salmon or affected their reproduction and growth, but which altered their behavior in order to make them more susceptible to other factors. With this, I mean, this is a kind of example of what we just talked about. Sorry.
Yes, that's correct.
Okay. So I just want to give some examples and perhaps discuss some of them with you. Neurotoxicity, the next paragraph. And if you look at it, it says genetically, where it says genetically programmed behavior. Genetically programmed behavior, such as migration timing, is triggered by external stimuli, which involves the brain and nervous system. For this reason, a neurotoxic effect is perhaps the most likely scenario for a possible contaminant-related basis for the observed change in sockeye behavior. Would you agree with that statement? Was that something that you would consider to be a likely sublethal effect of contaminants?
I think that's a reasonable hypothesis.
It's a reasonable hypothesis, yeah. And over on the next page, 1.32, and this is something that I was just curious as to whether you're aware of this work. Chemical imprinting has been shown to attract fish toward a spawning stream, suggesting that olfaction, the sense of smell as I understand it, is connected to migratory behavior. Are you familiar with some of the work that exists to study the connection between the ability to smell and the ability to find the natal streams of sockeye salmon?
Yes, generally.
And I think 1.3.3, endocrine disruption, you've discussed to some extent effects such as feminization, masculinization. Those kind of issues are things that we've already talked about. 1.3.4 is something I want to talk about, maybe just ask you about. Osmoregulatory disruption. And we've discussed earlier about the sensitive life stage from moving to freshwater to saltwater and saltwater freshwater. Is that what's meant by osmoregulatory disruption?
Yes. Well, it's a disruption in their ability to move efficiently and successfully between freshwater and saltwater, or vice versa.
So a contaminant may not have a direct lethal effect, but if it somehow inhibits the ability of fish to make that transition, it could leave them susceptible to other forms of predation or disease or parasites.
Yes, if they're unable to make this transition effectively or efficiently, they're potentially more highly stressed at that time when they're trying to make these transitions, and that makes them more susceptible to other types of for example, the disease organisms, or like you say, potentially to predation as well. And
there was quite a celebrated study, and I think I saw it in your bibliography, by a gentleman named Fairchild of Atlantic salmon back in 1999. And it's my understanding, perhaps I'll leave it to you, ask you to explain what you know about that study. I understand that this was an example of trying to determine why certain Atlantic salmon were not returning to their spawning grounds. This is in, I believe, in New Brunswick. And it was determined that there was some impact on pesticides on osmoregulatory disruption. Could you, I'm probably not getting that quite right. Do you have some familiarity with that study?
It's been a little while since I looked at it specifically, but yes, what it showed was exposure to, in that case, I believe the pesticide was atrazine, which is a herbicide. I may have that.
I think it was matacine, I think was what it was called, and it was like one of the surfactants that you talked about earlier on, that it was applied or applied with a pesticide to deal with spruce budworm, I believe it was.
Right. So the bottom line was that the animals that were exposed to these chemicals had impaired ability to transition from freshwater to saltwater, and so that is consistent with this concept of osmoregulatory disruption.
Right. And so here, in the context of Fraser River sockeye salmon, Dr. Ross and Dr. Johannesson are suggesting, this is in the second line, that osmoregulation is particularly complex for salmon because they are anagenous. Therefore, their process of osmoregulation must change dramatically as smolts and again as returning adults. So that, again, that's a particularly vulnerable life stage for them. And at the bottom of the paragraph, it is possible that a contaminant or combination of contaminants could disrupt the osmoregulatory changeover such that the salmon would need to get into freshwater as soon as possible rather than waiting for the usual migration trigger. Would you agree that that's a reasonable hypothesis?
Yes, indeed. That's reasonable.
And this doesn't exclude other contributory causes, I suppose, such as changes in temperature and other kind of climate or human-caused changes that may also impact this behavior as well. It could be one of a number of effects that cause this result.
Yes, it could be additive, or, for example, or synergistic in nature.
And just quickly on the rest of this report, it talks about immunosuppression as something you've talked about, that these chemicals could reduce the ability of salmonids to fight off disease or parasites. And finally, on the next page, 1.3.6, and this is something that I wanted to discuss with you because I think it's relevant to the issues of contaminants in Natal streams. Under developmental effects, and we talked about just now, early life stages of aquatic organisms can be more susceptible to some of the effects described above, such as neurotoxicity and endocrine disruption. And that, do you agree with that? That's essentially what we had discussed a few minutes ago.
Yeah, that's what we often find, is that the early life stages are the most sensitive to these types of effects.
If I could then go to, I just want to follow up with something you said earlier, and it's page 53 of your report. And this is something you spoke to earlier in the last paragraph. In the Fraser River Basin, both spawning and incubation habitats and adult upstream migration habitats had a higher percentage of measured chemicals of potential concern exceeding toxicity screening values during the post-1990 period compared to the pre-1990 period. And you had gone to table 4.50, and then you concluded, these results suggest that water quality conditions have degraded over the past 2 decades. However, the results were reversed for the juvenile rearing and smolt out migration stages. Now that's with respect to the chemicals that you had filtered down to in your chapter. I believe this is chapter 5. These are your chemicals of potential concern. This analysis did not include the endocrine causing chemicals and the contaminants of emergent concern that you considered in the next chapter. Is that right?
That's correct.
And in fact, you say that, just to be fair, on the next page, page 54 at the top, you're very clear that many other substances have the potential to partition into water and may pose potential hazards to Fraser River sockeye salmon stocks, and you go through many of them. And you talk about how there's insufficient data to characterize exposures to these contaminants and/or toxicity screening values were not located for these substances. As such, it was not possible to evaluate the hazards posed to sockeye salmon in the Fraser River associated with these contaminants. So, just to be clear, when you're talking about the exposure of particularly vulnerable eggs in the incubation stage in the sediments, or fry in their rearing habitats, your comments on page 53 were not related to these endocrine disrupting comments, the contaminants and these contaminants emerging concern. They may still have an impact in these Natal areas.
That's correct.
Okay. Let me step back a bit, and so you went into great detail, and I appreciate it for the discussing the data gaps. You've been very clear about that. And there's a few things I just wanted to follow up on. I just had some clarification questions. You mentioned in response to a question from Ms. Baker, and I just want to confirm this, that you felt it necessary to study data back to, I believe, 1965.
Yes, that's correct.
And I guess that's intuitive in the sense that if you're going to study the decline of sockeye salmon starting around 1990, you would want to go back historically to look at data that occurred prior to the commencement of the decline. And that's what you've done.
That's correct.
Okay. Now, I wouldn't mind going to table 3.7. It's just something that it struck me when I was looking at this table. And that's, I'm not sure the exact page number. I think it's, table 3.3 is T13. And maybe we can start there, table 3.3. What struck me in looking at this, and this is just an example, and you'll see this in a number of the tables under this heading, there's a lot of NA here.
I'm sorry.
Oh,
Just
sorry.
to be clear, were we going to look at table 3.3?
Go to 3.3 first.
Okay.
It's the same point really for all of them in this section. And really what I just wanted to ask you about Earlier you talked about, and you clarified to Ms. Baker, that when there is an effluent permit, that in your report, you identified a number of contaminants and went beyond what was allowed for or described in the effluent permit. But what also struck me is that for many of these companies, these industries, and this is 3.3, and if you go to 3.4 and 3.5, I think it's the same thing. There's an awful lot of NAs here. And here, NA means not available.
Data not available,
Data.
that's correct.
Can you explain why, when you say data not available, is it that data does not exist, or that you just were not able to, in the time that you had, or the circumstances you're under, to be able to identify and find it?
Certainly the latter and possibly the former. So we were definitely had major time constraints that prevent us, for example, from doing. We access readily available information for compiling this kind of information. And if we were able to get it relatively quickly, doing searches for this type of information, then it exists in these tables. If we were unable to get it, it's not in this table. One of the reasons potentially for not being able to get it is that it doesn't exist. The other reason is that it's not readily available. So I know that's sort of a fine distinction, but it's hard to, when you don't have something, to determine if it's one or the other.
So I guess then, if you were to take this conceptual framework, and if you had the luxury of more time and I guess more funding, you would want to be able to dig around to determine, A, I suppose, does this information exist? And secondly, is it available in a format that you can use? And you weren't able to do that in this report.
That's correct. So, if I was to prioritize the data that we would want to collect, clearly the types of information that we were most interested in was exposure information. So what are concentrations of contaminants in the receiving water system? And what are the effects of these chemicals? So what are the toxicity thresholds that we could use to evaluate individual chemicals? Now, for the purposes of developing the inventory of aquatic contaminants, the kind of information limitations that you've identified here, we believe are reasonably important, but don't necessarily change the overall outcome of our report, for example. If we had more time, we absolutely would have wanted to compile all of the information on effluent permits and all the variables that are associated with those permits. But more than that, we want to be able to know what's explicitly in those effluents. The kind of information that's on this table gets you partway to understanding what's in the effluents, but only partway. There's typically these effluents from sawmills or pulp and paper mills or from mines. They include very complicated effluents. They include many, in some cases, from pulp or paper mill effluents, hundreds and hundreds of substances associated with those. This permit information provides very little help in terms of identifying what those are. And that's why we've relied also on reviews of the scientific literature to provide us with ancillary information that allows us to understand more generally what do we see in pulp mills from general studies, not necessarily tied to individual facilities.
Okay. Maybe on a similar theme, but maybe moving over to questions that I have about the methodology and the determination of toxicity thresholds. Perhaps we can go to page 59 of the report. And I believe it's right above the heading toxicity thresholds for water. And I guess return to the theme that we just talked about a few minutes ago. And where it starts with, for the purpose of conducting a detailed analysis of the contaminants of concern. A toxicity threshold is defined as the concentration of a contaminant in water, sediment, or fish tissues above which adverse effects on survival, growth, or reproduction are likely to be observed in sockeye salmon, exposed for extended periods of time to environmental media that contain the substance either alone or in complex mixtures of the contaminants. In your experience in this report, were you able to obtain toxicity reference values that accounted for all of these different requirements to come up with a toxicity threshold?
Not fully, no. Typically not. In some cases, I would say yes. Things like, for example, cadmium, which is very well studied. The toxicity thresholds incorporate a lot of information on a variety of different endpoints on some audits. And so in those kinds of cases, we had sufficient information to be able to convince ourselves that the toxicity thresholds that we selected would be protective against these types of effects. But for many of the other types of contaminants, either there were no toxicity thresholds available, things like the EDCs and the contaminants of emerging concern, but also for certain contaminants that are more classical or legacy type contaminants, even they didn't necessarily provide all of the information that you need to understand the concentrations that are associated with sublethal effects like growth and reproduction. Typically, there's lots of data on survival effects. Typically, more but less so for growth. And then when you start getting into other types of effects that require longer-term studies to evaluate, then the amount of data drops off very substantially. And so there is only a subset of the contaminants that provide the kind of toxicity thresholds that would be protective against all three of those types of effects.
Now, I wouldn't mind discussing a little bit about the tools that you have to assess and to develop these toxicity thresholds. And maybe to use as an illustration, go to table 4.53. I'm sorry, I should have written down what the page number was. And this is where, as I understand it, you had an exposure threshold of greater. You bolded those exposure thresholds that are greater than 1.0. What were the source of the water quality guidelines? I understand you used the CCME guidelines and other similar type guidelines.
Right.
Could you explain a little bit about how those are developed? What are they for, and what is their purpose, and what is their focus?
Okay, so just as a point of clarity, so in the Chapter 4 analysis, we used guidelines, generic guidelines, like the Canadian Council of Ministers of the Environment, Canadian Water Quality Guidelines as a basis for identifying our toxicity screening values or similar values developed by other jurisdictions. And would you like to talk about those first?
Yeah, and I recognize that in Chapter 5 you developed more salmon-specific guidelines, and I'll get to that in a second. But I wanted to just talk a little bit about the ones you use in Chapter 4. And I'm just curious as to the circumstances under which those guidelines are created. Are they? My sense is that they're laboratory-based assessments, based on laboratory experiments, and not necessarily based on real-world situations.
Typically, what happens is that the work group on guidelines development will identify a substance that needs to be evaluated, i.e. guidelines need to be generated for them. Then a mechanism for getting that work done is identified. It may be a consultant that is asked to do a review of the toxicological literature on, for example, cadmium, to determine what its effects are. The available data is then compiled in a large database or in a series of spreadsheets, depending on how they do this work. And the vast majority of that, you're correct, is from laboratory toxicity studies, where individual contaminants have been added at various concentrations, and then organisms are added to those beakers, if you like, with the various concentrations, and then the effects of those exposures for whatever period of time are evaluated and used to calculate a lethal concentration to 50% of the population that was exposed, or an effective concentration if the endpoint is growth or reproduction to some proportion of that population, 20% or 50%. So those kinds of laboratory toxicity studies probably represent 90 to 99 to, in some cases, 100% of the data that goes into generating those guidelines. In some cases also there are data from work that's done in the real world. So for example, in Canada we have the Experimental Lakes area that's out in the prairies. That's where there are whole lake manipulations done as well, where a certain amount of cadmium is added to Lake 1 and a certain amount of more cadmium is added to Lake 2, etc. And then those effects are evaluated across each of those exposure scenarios under real-world conditions. But that's very much atypical of the type of data that goes into the guidelines development. Most of it is as you've indicated, this laboratory toxicity data from these very tightly designed laboratory studies.
Yeah, and these studies typically address one chemical at a time or one contaminant at a time, one chemical compound at a time in the studies?
So as you look back into the scientific literature, that was the most common approach years ago. Now we're starting to see more studies that are done like that with mixtures, either mixtures of like chemicals, for example, like mixtures of several types of pyrethroid pesticides, for example, or mixtures of polycyclic aromatic hydrocarbons. So you see these kinds of mixture type experiments happening more and more in the literature as we've identified the need to understand the effects of mixtures of contaminants more out in the real world. These kinds of data now are being generated under the laboratory conditions at least, and to a certain extent in the real world as well.
And also, often I think as I understand it, the aquatic organisms used for the testing aren't necessarily salmonids. These are guidelines are developed for other types of species. Is that rainbow trout, for example, or fathead minnows?
Yeah, typically the data that goes into the guidelines development is whatever's available. And so, for example, when there's sockeye salmon data available, those will be used, or pink salmon data are available, those will be used in the guidelines development for sure. But most commonly, you see fathead minnows and rainbow trout and various types of cladocerans, water fleas, invertebrates that are used in these types of tests, Daphnia magnus, Daphnia dubia. Those are probably the four main species that are used to generate more than 50% of the data that go into these types of evaluations.
So I would suggest then some caution, and I think you reflected this perhaps in your chapter 5, some caution must be taken in applying some of these guidelines to particularly sensitive species such as sockeye salmon.
I don't know that I would characterize it quite the way that you've stated it. And again, there are a wide variety of different types of water quality guidelines generated. In Canada, the Canadian Council of Ministers of the Environment are responsible for generating those guidelines. And they have in place a protocol for generating those numbers that are intended to be very protective. So notwithstanding the data that go into them, which is always a limitation, they're designed to protect the most sensitive life stage of the most sensitive species of aquatic organisms over an indefinite period of exposure. And the way that they get that is they look at the data that are available, identify the most sensitive toxicity threshold from the available literature, and then typically there is a safety factor applied to take a number that might be here and then drop that down by a factor of 10 or so to account for interspecies differences in sensitivity that you might see if, for example, some onids are much more sensitive than the species that were used in generating the toxicity threshold. But usually there's a requirement for having salmonid specific data in the database that are used to generate those guidelines. And so I consider the Canadian Water Quality Guidelines to be, of all the guidelines that are available in the world, they are probably the most protective.
I guess where this is leading to is that ideally it would be useful for researchers in this area to have guidelines that were established, first of all, specifically for salmonid species, and as much as possible rooted in real life, real world in situ situations, so that the data you have some confidence that that's relevant to sockeye salmon. Would that be something you'd want to see in the ideal world?
Yeah, well, the more specific you can have the toxicity thresholds, the higher level of confidence that you have in the results of your assessment that is conducted. So that type of information that allows us to identify very specifically toxicity thresholds that are specific to salmon is something that we'd be very interested in. I just want to caution, though, that developing that kind of information in real-life scenarios is really challenging from the standpoint of in controlled studies. You can certainly develop epidemiological type information and use that to generate toxicity thresholds, but to design these types of controlled studies that get to real life toxicity thresholds that are reflective under real life exposure scenarios, they're challenged. We've done them in certain cases by using recirculating stream systems and then to do our exposures and then comparing those to results of exposures that were done under typical laboratory conditions and comparing those. So you can get there for sure, but these are challenging studies. But we definitely would love to have more of that kind of information. Yes.
Okay. I think I'll change focus a little bit and the time I have left and talk a little bit more about some of the sources, potential sources of the endocrine disrupting contaminants you've discussed and these contaminants of emerging concern, recognizing they're not necessarily the same, but there's significant overlap in those two categories. And this is your chapter 6. I'll just ask you a question about pulp mill effluent. And perhaps I can have tab 4 again, Johannesson and Ross, and it's ringtail, page 27. So in this paper, it's discussed, Drs. Johannesson and Ross discussed potential sources of these kind of contaminants that could perhaps explain the apparent change of behavior in late-run sockeye salmon. And then, so ringtail, page 27, 28, it's a different page number on the actual, page 15 on the actual page. Actually, well, first thing, before I get the pulp mills, perhaps I want to talk a little bit about wastewater. And you've identified, and I think this is consistent with what I've seen in literature, that the two main point sources of these kind of contaminants appear to be municipal wastewater treatment plants and pulp mill effluents, as well as the various sources from highly urbanized areas, industrial areas. Is that right?
That's correct. I'm
curious, a couple things that struck me about the wastewater treatment, and one question I'm not clear on. And I imagine we'll get a lot more evidence in the hearings to come about wastewater treatment plants and the benefits of primary, secondary, up to tertiary treatment. Do you know if secondary treatment is effective in screening out these chemicals of emerging concern, especially the endocrine disrupting chemicals? Is that an effective method to screen out these contaminants?
That is a very broad question.
Or some of the contaminants. Perhaps you can maybe just give me.
We recently completed a project for the U.S. Fish and Wildlife Service where we looked at, we essentially developed tools for them for screening biosolids. And as part of that investigation, I looked at several studies that provided some information that would lead you to believe that at least some proportion of some of these chemicals that we identify as EDCs and emerging contaminants are primarily or in large measure associated with the solid fraction. And so a treatment process that removes solids from the wastewater treatment plant effluent would have the net effect of removing some of the loading of these contaminants to the receiving water systems. So I'm not sure that I fully answered your question with that answer, but that's how far I feel I can go on that.
Well, no, that's fine. And maybe what I'll do is I'll tell you what Dr. Johannesson and Ross said about it and see if you agree. And it's at the bottom of this page, and where they say, and they talk about secondary and tertiary treatments, various grades of treatment of chemicals, of contaminants. And here it says secondary treatment involves assisting in biological breakdown of organic matter. And I understand that that's a process whereby some of these chemicals of concern, especially the ones that bind with particles, will attach themselves to the particles in the sludge and then be removed and not put back into the water. Tertiary treatment can involve chemical treatment and a variety of filtration techniques to remove even more contaminants. So while there's no doubt that wastewater treatment is an important step in the reduction of human pollution of the environment, there are 3 caveats that come with increasing treatment levels, and I think this is what I wanted to ask you about. First, the greater the treatment, the greater the quantity of sludge produced that must then be treated before it can be disposed of. This sludge is known to contain a variety of contaminants, including PCBs and other toxic and persistent compounds. And I guess included in that would be some of the pharmaceuticals and some of these other type of drugs that have been flushed into the system and into the wastewater treatment. I mean, these are the kind of things that are building up in the sludge.
Well, just to be cautious, I fully agree with this first statement that things like PCBs, those contaminants that have a high affinity for organic carbon that tend to partition into the solid phase, those are absolutely going to go with the biosolids. Keeping in mind that many of the pharmaceuticals that you're describing are also highly water soluble.
Okay.
And so the effectiveness of the treatment in terms of reducing those may be different. It's likely to be different than what you would see for these contaminants that are most strongly associated with the particulate fraction.
Okay. Well, that's a useful distinction. What struck me is in the next line is that at least for those particles like PCBs and others, persistent compounds that would remain in the sludge, in here it says that in some cases the sludge is often used as soil treatments, fertilizer in forestry and agriculture, where these contaminants can later migrate into local surface waters. And it talks about a product called a Nutrifor that was recycled and marketed as a fertilizer, and especially as a forestry fertilizer. Are you aware of that?
I don't know that specific product, but the application of biosolids to upland areas for those kinds of applications is something I am familiar with, yes.
Okay, so that's one example of a possible non-point source contaminant that could leach from these upland areas into sensitive Natal streams, rearing habitats that could impact sockeye salmon.
Yes, absolutely.
Bruce, would this be a good place to?
Yes.
Hearing we now recess for 10 minutes.